Okay, as promised, I'm going to review the COP 1000 MagicMixture assignment. When you do the MagicMixture assignment, first thing you want to do is analyze the assignment definition and specifications. So from the left, keyword is magic, no such thing. MagicMixture implies there is going to be some type of formula that you're going to have to invent, and yeah, this is some type of an assignment. In the specifications, I believe I did include for you what I call some sample runs. So if we entered 2, 3, 4, 5, I should see these values. And if I entered this, I should see these values, and so on and so on. So our goal is going to be to write code to where when we enter these values, we get these outputs. Let's see if we can do it. So pseudocode for MagicMixture. First, we're going to get the 4 chemicals. Then we're going to write that formula, then we're going to remove whatever fluff, and then we're going to display the results. So here's my comment header written by myself when I wrote it. Read, understand, and code some bogus formula. So this is the MagicMixture. Here's my preprocessor directives, my stdio, my stdlib, and notice I added something new called a define. And I'm going to define an alias, capital PAUSE, for this command system pause. I'm going to do this because I'm lazy. So PAUSE is now the same as system pause. So PAUSE is now the same as system pause. So if I feel like using a system pause, no problem, I can. And if I feel like just using the capital PAUSE, I can use it in replace of this. Notice I put all caps because this is now a constant. This value is never going to change, and constants are always written in capital letters. Okay, so my program begins with me defining some variables. So my first variable that I'm going to define is lithium, osmium, I believe that's mercury and krypton. Then I'm going to keep track of what's in my current mix, and I need to keep track of the original values for these and the running values for these. And at the end, I'm going to display the number of gallons and ounces. So the very first thing you're going to have to do is get the 4 inputs. I believe there's 4. Let's take a look. So enter the total ounces for lithium, osmium, mercury, and krypton. Scan, 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 and scan. Notice this time these are all floats, not ints. So there's my print and scan, print and scan, print and scan. If you recall, I'm going to save the initial values. So Li is going to Li2 and so on. And I'm going to output. First thing for the user to see is what they just typed in. So they're going to say, starting values was lithium, some number, osmium, mercury, and so on. And now I'm going to follow the rules of the assignment, and I'm going to start adjusting the mix. So I'm going to say mix equals the new lithium, mix equals the new osmium. And, now I have hydrogen. Hydrogen is going to be the original hydrogen plus or times whatever osmium is. Osmium is going to be whatever osmium is plus whatever's in the mix times number of lithium. So I'm going to take my mix and I'm going to double it. I'm going to add to my mix what was there times lithium 2. And follow along, and when I'm done, my ending values should be correct. So this will be my ending values. Here I'm going to convert ounces into gallons. There's 128 ounces in a gallon. So if I take the remaining ounces equals the mix minus gallons times 128, and then here's my final statement. Let's run this and see what happens. Okay, so I'm going to start by entering the first set of values. So I'm going to go 2, 3, 4, 5. and my starting ounces was 2, 3, 4, 5, and then as you can see, 2 becomes 6, 3 becomes 13, 4 becomes 12, and 5 becomes 7.5. 6, 13, 12, and 7.5. As you can see when we ran it, no gallons, 38.5 ounces. No gallons, 38.5 ounces. That's run number 1. That's run number 1. Let's run it again a second time. So here we go. Here we go. Try number 2. This time what we're going to do is maybe use a different set of inputs. I think I'll do the 9, 10, 11, and 12. So here comes the 9, the 10, the 11, and the 12. So if you look at the specs, the 9, 10, 11, 12 should become 27, 181, 110, and 18. Total ounces, let's take a look at that. Total ounces, 336, 336. Right here, it's my 336. So basically that's going to be 2 gallons and 80 ounces, and there it is. 2 gallons and 80 ounces. 2 gallons and 80 ounces. So basically you can continue to test this program as we've done in the past, and you should get the same values I got. So here's the program one more time. The comment header, there's my pre-processed directives, setting up my variables, getting my inputs, echoing them to the screen, preserving them, and then just starting to do this this calculation. And notice the HG, the OS, KR, and the LI. That's just for my output so I can show the ending values for these chemicals. The mix is the running and the total of the magic mixture. Over here is, I'm going to show gallons. That's just nothing but mix integer division by 128. Boom, there's my gallons. The remaining ounces would be the total of the mix minus the number of gallons there was, and there we go. There we go. I believe that works. If you have any questions, let me know.